Hi, welcome to another exciting edition from Hyperactive Studios. My name is Nathan Thorne. This is for Python, video number 5 actually, and we're going to be continuing off loops. We're going to have a look at for loops, but before we start doing that, let's look at a few more things dealing with lists. Let's see here, bus full of children. Okay, so let's look at what would happen if we were to want to add another child to our list here. So if I say something like children right here, and then I say dot append, I can add a child to the end of our list. And maybe it is, I don't know, Johnny. Johnny sounds good. I don't know. Alright, there we go. And we'll add Johnny. And Johnny will need to have, let's call car full of children afterwards. Open close parentheses like that. And instead of having car full of children, we're going to do bus full of children down here. And so now it calls this function up here. Anyways, this function up here, which then calls this function up here. Again, I had to put the car full of children before the bus full of children because we're calling the car full of children in the bus full of children. It'll make more sense here in a second as to why we're doing it this way. Okay, so let's go ahead and save. Let's just run this real quick. Okay, so we have now Sally, Bob, Billy, Jill, and Johnny, and they all are working in here. So this is pretty cool. And I could even add in a message, something like, who gets on the bus? Well, Johnny gets on the bus, really. Print. And, Johnny gets on the bus. So that's kind of cool. And then now if I save, and this way we're kind of like simulating a bus going around and doing it stops. So Johnny gets on the bus, and then we get all these messages happening here. So that's kind of neat. So that's how you can add another item to your list. Now, this is pretty neat, and it's pretty cool. But one of the things we might want to do is maybe we have like a whole set of children. We call it children to pick up. So these are children that need to be picked up. And maybe we have a list already set up with that. And I don't know. So let's add Johnny into our list because we already have Johnny here. Let's add gosh, who knows? April, Mandy, oh gosh, Rose, I guess would be in one, right? Richard, what's some more here? I don't know. It's really whatever. Phil. All right. We could add another one. Nicole, etc. Donnie, etc., etc., etc. So these are children that would need to be picked up on the bus ride. And these are already on the bus for whatever reason. They're just on there already. So what we can do is, remember we had this random int set up here? Pretty cool. But we could do something more with this. And one of the things we can do is over here for our children append, we can append a certain child, but we need to append children that are going to need to be picked up on the bus ride. So let's do that. Okay, let's do that there. And then we need to select a particular child to pick up. Now, we don't want to pick up the same child every time. That would be a problem, right? Unless we start cloning children as we go around to each bus stop, that might be a bit of an issue. So we don't want to do that. We don't want to clone children. We only pick up a single child from the list, but that does mean that we have that child. Except we're going to need to remember which random child that we did pick up. That is going to be an issue. So this means when we do our random integer, we need to do it ahead of time. So we're going to call this maybe like child select for our variable equals, and then what child are we going to select? Well, we have our random int, and I am a big fan of not doing extra work. So we're going to copy that right there. Pow. Now I can say 0 in here, but I believe I can also just say, believe random int starts at 0, just like the other one. Imagine that. Just like random range. Well, yeah, random range is another one. Starting to think about it. So yeah, it's kind of cool actually. Yeah, but we do need to remember this thing. So random int, and I could do the length of. Okay, so random int, and then do the length of children. Children. Is it children pickup? I think it is, right? Yeah, children pickup. Right, pickup like that. All right, cool. And that basically gives us our child select. So whichever child gets randomly selected out of the list of children there to be picked up, that's the one that gets picked up. And then on top of it, if we want, we can come down here afterwards and we can remove that child. So basically what we do is we come in here and we say children pickup dot remove, open close parentheses, and then inside there we're going to say the one we have, which is child select. So that's the selected child that got on the bus. Well, they no longer need to be picked up, so we need to remove them from the pickup list. And we need to essentially after we picked them up. So when we append them, essentially we're picking up the child, and now they're going to be also complaining when they're going to get there. This is an unrealistic scenario. If the children are going to school, they're not going to be wanting to know when they get there because they're going to want to not get there more likely than not. So maybe not the most realistic simulation for children on a bus, but if this was a school trip, though, it might be this might be realistic. So let's see here. So I guess it all depends on the scenario, right? And I made a mistake somewhere. Awesome. Okay, so I do need to have that starting value. My mistake. So random int here. So we do need to say 0, comma, and then len. So that does matter. And we need to have which child it is too. So basically we have child select here, but we need to know which child, but what's the actual child object. So in order to do that, I can say children pickup. I'd actually probably write this in a simpler manner, but this will work. Like that. And so now we're saying which child from the child pickup, that's the one that needs to get removed. That particular element. And there it goes. It works great. So Johnny gets on the bus, and Johnny is no longer needing to be picked up afterwards. But the problem is now it says Richard is the one that got on the bus, but we still say Johnny gets on the bus. So it's a bit of a problem. We don't want it to do that anymore, right? So, but remember, we have that child select in there, so this comes in handy yet again. So one of the things we're going to need to do is add append the child's name on the bus. And then we need to remove the child afterwards, because otherwise what's going to happen is that we won't be able to access that child, and that would be a bit of a problem. So in order to access the child that's getting on the bus, we need to do this number right here. Right. There we go. And now we're saying what child is getting on the bus. Now we had to do that before we remove that child from the children that need to be picked up, because otherwise we wouldn't be able to select what child it is that just got on the bus. We didn't store the actual child. We stored what position the child existed inside of the children pickup list. So and what I mean by position is which element in here. So that's position 0, first element, position 1, second element, position 2, third element. You get the idea. So basically with our child select, we're saying which one of these is getting selected. And so we're going between 0, which is this first element, all the way to the end of the length, which is that element there of our list. And so we are selecting which child we're going to be picking up on our bus ride. Cool. And we need to make sure that we are saying this message before we remove that child from our pickup list. Otherwise, we won't be able to access it, right? Because if the child's not there, that position is going to be giving us a totally different student's name, child's name, and that would be a bit of an issue. So we don't want to do that. So let's run the module again, and now we're going to say Donnie gets picked up on the bus, and Donnie is saying now, are we there yet? Are we there yet? Are we there yet? Etc. Awesome. So there we go with our list, and it's working great for children who get picked up on the bus. So obviously, we need to do this several times. And one of the things we can do is we can see that we keep doing this until all the children are picked up on the bus. Now, we don't have to, we can make this more and more complex, and I'll show you. Let's start out simple here at first, and then we'll make it more and more complex. So let's add a while loop. This is another type of loop. It's called while. And so while, let's say here, length of children pickup is greater than 0, we're going to continue the loop. So that condition is that it's just going to keep, looping until we pick up all the children. Basically what that means. Because think about it. Len gets the length of how many items are in a list. And in our list here is children that need to be picked up, right? And so if we have more children than 0 children, then we still have children to pick up on the bus. Cool. Now let's run this as a simulation and see what happens throughout the bus ride. And list out of range. Ooh, managed to go one too many. All right. I think I know what's going on, and I want to show you what's happening. All right. This random int, I might need to do a -1 at the end because it may not just drop off 1. I'll just do that. See if it fixes it real quick. If it does, then we know that's not an issue. There we go. That was it. So I figured. You're probably going, what? Hold on. We'll explain that in a second. And so we kind of can tell when different children are getting on the bus. Can you imagine typing this up by hand? This is the power of programming for you. Oh my gosh, it saves you so much time and effort. It's not even funny. But anyways, we can see different children getting on the bus and being picked up throughout the bus ride. And the whole conversation going on between the bus driver and the children, each child, as we pick up each child on the bus. So here's the thing. This was 0 to 4, or however, not 4, but however many elements were in the list. And so it was actually doing that last number. And again, remember, since it starts at 0, that's a bit of a problem, right? Because we need to do one less than however many elements are in this list, because since you start counting at 0, to deduct one from the total number of the list. So 0, 1, 2, 3, 4, 5, 6, 7. But there's 8 children on the bus. So if we say 0 to 8, that's a problem, right? Because we need to go 0 to 7. So that's why I said -1 here on the length. So when I do length of children pick up, it comes back as 8. And if I subtract 1 from it, I get 7. So now it's 0 to 7. And now I don't have a problem of accidentally selecting a child that's not in the list, which is exactly what was happening. We were selecting one child more than what was in the list. And so that's why we were getting that error earlier. Okay, let's see here. Boom, boom, boom. And there's all that. So very, very cool. And that's essentially how that works. And the way this while loop works, it just keeps looping over and over again until this condition is no longer true. So the moment this condition is false, it stops looping, and it goes on to the next line below the loop. So, which is right there, the end of the function, matter of fact. So, might be going, well, that's cool, but usually on these bus rides and stuff like that, we actually end up picking up more than one child. Usually, we don't just pick up just one child. So, let's do that. Let's add several children at once. And let's create a new picked up. It's kind of confusing, but oh well. It means, not to be picked up, or that are actually picked up. And we need to do append here. Append. And we need to append a child to it. So we're going to randomly select the child. We're going to do another loop here, basically. And we got our child select, but we're also going to do a random number of children to pick up. So this gets kind of cool. Num children pick up. So this is the number of children we need to pick up. And it's going to equal to random int range. So it could potentially pick up all the children on a single bus trip. It's a possibility. All right, and then we're going to say while num children let's see here. I'm going to do a for loop on this one. I could do it either way. I could go either way on this. I just feel like doing a for loop. So for count in let's see, random range. No, I'm not going to do random. It's just a range. It's kind of a cool way to do it, though. We'll stick with this. Length. Alright. Length. And then, what's the length of it? Well, it's going to be num children to pick up, right? Okay. And then we're going to do a child select each time. And we're going to append a child. And the child gets appended. So the child picked up here gets appended to this. So we need to say which child this is. I guess technically we don't. We could work around without having to do that. And then we just do car full of children outside of this loop and keep it like that. So technically, I think we can get away with not having to do picked up, which would be nice if we don't have to do that. Saves a little extra effort. I was just going to do it where I keep track of how many children got picked up and which children got picked up, and then add it. But really don't have to, since we're looping through this one by one, and we're randomly selecting the children that are getting picked up on this. It'll be fine. So that'll work out. And this is going to happen for each time we pick up a child. And then afterwards, we'll end up saying how many children get on which children get on the bus, and we'll say what happens for interaction at that point. Okay, so one of the things we had to do here was change the minus sign on this random int, and also take away -1. We had to remove that -1, so we had -1 right here, and that was great for that particular thing for child select. But in this case, we want to always at least have one child get on the bus, so we need to start with 1, and we always want to be able to go up to a potential full number of children that could get onto the bus, so that need to be picked up. So for that reason, we're going to remove that -1 there, and then that gives us, that way a child always gets on the bus. And then we don't need this line here anymore. And we should be good to go. Run the module. Boom. And there we go. So we can see that Nicole got onto the bus here one time. And we had 6 students get on the bus all at once here. And we had 1 get on before that. I did another simulation run earlier. And I had 2 get on the bus. Then I had 3 get on the bus. Then I had 1 get on the bus. I had 2 get on the bus. So you can kind of see how this works. And it's all very cool. So that should give you a good idea and good somewhat understanding of how nested loops work. So every time I go and do one of these outer loop iterations, this loop here has to loop through all its iterations first. So it does it. All these loop iterations, 1, 2, 3, 4, however many there are, handles them all in here, then goes out and then does the next outer loop iteration. And it keeps doing it until this outer loop is done. Once the outer loop finishes, then of course we never do this inner part, because it skips this whole block of code. A whole block of code. Yeah, all the way through there, which is essentially the whole function. And so in this way, we now are simulating a bus of children getting on. This is pretty cool. We don't have to, in the real world, you wouldn't have to necessarily have you would want to remove the part where the kids are complaining about when they're there yet, but you could do this with any number of bus stops. You could have random number of bus stops, or you could have actual bus stops put into a list like this, and then you can sit there and simulate a bus going between the different bus stops along with lengths and distance between them, and then you could determine the best routes for buses to drive. And you could have it set up where, this bus stop must follow after this bus stop, or based on, where they are in position to each other. So, for instance, you wouldn't select a bus stop that's like way across town from another bus stop. It'd be like one of the next bus stops, physically, distance-wise, would be one of the next bus stops. You could do something like that, and then this way you could actually simulate and determine everyone's bus route, optimum bus routes for all the bus drivers for an entire region or area or United States or another country or whatever. You could do that with this. It's pretty cool. You'd have to make some modifications to this code and everything, and determine lengths and distances, and is this a possible bus stop of another one type thing. But I mean, if you did, that'd be cool. You could also even determine whether or not making rights or lefts was going to have to wait in traffic for safety before you could go, and what the optimal bus route time would be, and to determine and calculate the time. You could actually simulate how much time it'd be based on stops and stop signs and all this stuff. You could put all that in there and determine how much time it takes to drive from one spot to another. and does figure out where you're not loading up one bus driver with too much driving time. So even though that one bus driver might be picking up fewer children, they may have a longer bus ride because maybe they have to stop for more stop signs, more stoplights, whatever. You could literally set that up in a program like this and simulate all that. And it's really cool. I mean, it's amazing what you can do with this. With code, you can do literally just about anything, and you can automate so much stuff. I mean, it's just amazing what you do. You could even do it for traffic lights, or I mean, think about it. There's just so many things you can do with this. But anyways, I was hoping you guys enjoy that. And in the next videos here we're going to have coming up, we're going to start actually putting together the game. We started talking about doing the game here, so we're going to actually start putting together enemy classes. I'm going to reveal objects, and so that way we can simplify our stuff. We've been using functions to simplify things, but we can further simplify things and make it to where we basically organize our code even better than what we have been, and make it to where it's easier to work with what's called objects. So instead of having like child just by its name, we could have all kinds of different attributes of a child, like maybe their running speed or something like that. The height of the child, what we could actually determine all this stuff, and we could store it into what's called an object, and then that child takes on more than just a name. It has all these attributes. We could do the same thing with a car, how many car doors it has, how many wheels it has, or just be aka a vehicle in general, and then we have a car class coming off of a vehicle. And so we can do what's called inheritance, and then we don't have to basically rewrite a whole bunch of code. Instead, we define a base set of code, and then we reuse it. So it saves us from having to type as much. It saves us time to do as much work and as much thinking. It simplifies things. It makes your development go way faster and way easier. And so I'm going to show you an easier way, basically, to go about coding this stuff in the next video. So with that, my name is Nate Nessler, and this is for Hyperactive Studios. Thank you very much.